Well, if you've seen any of my videos before, you'll know that this is quite a bit of progress with all the painting that goes on in the schematic. Now, this is part 4, I believe, of the Philips BX750A, and along the way I've had a few sidetracks like the output transformer, but right through the process I was changing and checking components, and the result is what you see here. Now, this part was done right in the first or second video where I showed you the correction or the checking of all the components of the power supply side. The next stage was the output stage, because it was provoked or prompted by the one output transformer that was blown, so it obviously drew quite a bit of attention. This is the one that was not blown, so this one was intact. However, there were quite a few components faulty here. You can see the capacitors were changed. That's pretty obvious. It's these guys, and they are terrible. Say no more. But other than the capacitors, I noticed something with this radio. Contrary to what I've seen with some of the other radios, like the GRUNDIG, the GRAETZ and so on, these resistors have not proven to be as good as the ones that I've encountered before. These guys were atrocious. This 180 here, which is important because it's the main biasing capacitor, this thing was reading something like 300 ohms. So I replaced that with a 180. There is no capacitor here. There's no cathode bypass cap, but in the radio itself, this thing was in place. And it would make sense unless it proves to be a little bit too bassy, which I think might be the case, in which case I might remove it. I replaced this. This is a Sprague Atom, 100 microfarads at 50 volts. It was leaking like crazy, completely over value. And I put in a small one, a Nishikon, in there, which I may actually remove because I think it's proving to be too bassy, and I'll explain why in a minute. This 820 was up to 1.7, more than double. This 1K was reading 6K, so that was replaced as well. So I got this base output stage to as good a value, as good a working operation as possible, and then moved on to the next one. The next one obviously was the other output stage with the blown transformer. So the transformer was replaced, as I've shown you, and then all the other components were checked. These weren't so bad, these resistors, within the 20%, just within the 20%, so they were left in place. These caps were fine. This one was bypass cap. Now this is a 470 nanofarad bypass cap, which is a bypass for the cathode resistor of 220, and it's 470 nanofarads, so that it only really amplifies the higher frequencies. So it makes sense, but it was leaky as hell, so that was replaced as well. Then we move right along backwards, and again around the this is the treble pot. Some of those resistors were changed. That one there. These over here are around the second triode amplification stage of the ECC83 or 12AX7. These capacitors were all needing change. The rest of the components, as I said, these are all resistors and pots. They were within the spec. They weren't too bad. They were within the spec, but not as close as some of the GRAETZ components used to be. So going backwards, you've got the second. This is the second amplification preamp stage, the first preamp stage. If you notice, we're still in the audio stage. This is all the AF section. We haven't actually got to where the inputs of this AF section are, and we'll get there in a minute. So this thing was all checked. The ECC83 is fine. And then we come to this. This is the switching network, and this switching network is the one that determines what exactly goes into the amplifier, into the audio amp stage. And it receives both the FM and the AM signals, as well as the pickup input. What this does then is it selects between the input from the tape recorder or the input from the radio. You see these two over here. I beg your pardon. This is the pickup input and this is radio input. So depending on where this switch is, it's either passing through the radio signal coming from here or the pickup input coming from down below. And it's this middle switch really that does the operation. If it moves up, it brings the pickup. If it stays down, it's sending the radio signal through. Now, how the radio determines what's sent through, whether it's AM or FM, is with this switch. Because this switch receives two signals. This is the output. These two, one is from FM and one is from AM. And those two signals are generated up here. The generation of the FM audio comes out of here, out of this signal path here, comes down. It's the one on the right here. It comes across, down and into 0.6 over there. The audio for the AM is generated across at the bottom really of this coil S34. It comes down here, goes there, follows this down, comes to here. This section also has a DC voltage which is negative, which is the AVC voltage for AM, which then goes off that way to the AVC circuit. But it also comes through this 180K. This is a resistive divide, 180, 150. So basically half the signal goes up there, up there, up there, up there, and there's the other input. So depending on where this switch is, you got FM or AM. This is actually switched when you push FM. When you deactivate FM, all the others keep this in the same place. Okay, so we've determined where the audio comes from, and all that was checked and done. Then I went back, further back, just to get one thing out of the way, the AVC. Now, the Magic Eye was completely buggered. There was no signal whatsoever. It was this resistor. It's one of those funny ones. That's that resistor over there. It was reading about 1.5 meg. It's supposed to be 470K, so that was replaced. The tube was still dead, so that was replaced. And it was replaced not with an EM80, which is very difficult to find, but I got one from Russia with Love. It's a 6E1P, which is a direct match for this one. Just fit it in. I got a new all stock one working brilliantly now. Resistors, that resistor replaced, that cap replaced. This thing started working very, very well. Now, where does this signal come from? This is a indication of the signal strength. This is the AVC voltage really. So that comes from here. And where does that signal come from? Well, if you're on AM, we've determined that the AM signal comes from there, down here. And it's got a negative DC voltage, which is the AVC voltage, and that then goes through that 2.2 meg and off to the AVC circuit. The FM AVC is the different one. That comes from there, comes down here, across there, don't lose track of it, down here, through that 5.6 meg, and that's where it then joins. That then goes off to the AVC. So one is reduced by 2.2, the other one is reduced by 5.6, and you have your AVC voltage, which then goes across here, and then of course to the respective grids of the previous tubes to control their gain. The detectors, well, there's the FM. That resistor there, 180 ohms, that was reading 350, so that was replaced. Although, as you may remember, it was picking up FM quite well, but that was replaced. Everything else seems okay. That capacitor was fine. Then, I beg your pardon, that capacitor was replaced. That's badly marked on there. That was this guy here. And that was replaced because it was reading way off the charts. I should have a red stripe across there. And then the AM detection is over here. And again, all the components there seem to be fine. These are the IF transformers for FM and AM. And you follow the signal back and you hear at the output, and this is where the signals are actually coming into the IF transformers, or that stage, the second IF transformers. So again, all these components were within spec, so they just get checked, painted, connections checked, and so on. And if we move back, where does this signal come from? It comes from this section here, this IF transformer. And then previous to that, we have the mixer oscillator over here, which takes, this is the oscillator section and the RF section over there. So it takes all this and it then creates the IF frequency mixed with the signal frequency coming in there. So there's your oscillator, everything okay there. You go back one, we've basically got an IF, an RF amplifier section here before the mixer. And that then receives signals from the two, from the FM section down here, which is two tubes, EF80 and ECC92. ECC92 is actually a single, basically it's a single ECC83. It's one triode, and it's being used here as a mixer. That's RF, that's mixer. So the signal goes, comes out of this IF or this transformer, goes up here and to the switching circuit. Anyway, these two stages are actually working quite well. I know the FM is working quite well. So if there's one thing I've learned about the RF sections, it's be very, very careful how much checking you decide to do, because you can do quite a bit of damage. Some of these components you need to desolder to check. Now, if you mess around in this area, sometimes just the way the leads are connected or lying around, or where the spacing is between leads can actually affect the whole circuit, create oscillations and so on. So I did some random checks here on resistors and so on, and obviously on continuity, which is easy. They're fine. I didn't even bother painting them because I really didn't change anything on here. The same applies to this RF section for the AM. This is the switching for long wave, medium wave, and short wave. You check continuity, you check that it's receiving, do some spot checks on resistors if you can, and be very, very careful, because you can really mess this up. There's a lot of little coils running around here with little fine wires. You've seen that before, and you've probably also seen what can happen if you accidentally pull one of those. You don't even see it. The thing just stops working. So anyway, that's a long explanation on how this paint job got done. Now let me show you the radio itself. Some of these components are the ones around the volume control, and there's the solution to the proximity problem of that transformer to the tube. A little bit of clear PC board is between the two, so we don't get any shorting or any overheating. So on the top section here, what you see is very few components that actually needed changing, but we do have the audio amplifier stage here, which I'll turn this around so we can see. So quite a bit more work was done here, as I've mentioned in the schematic description. Things like the bypass cap, that's the 100 microfarad, which I might remove if it's too bassy. This is the resistor that was reading high. Couple of other resistors that were indicated in the schematic, the capacitors. So the changes in here were a little bit more than in parts of the other parts of the circuit, primarily because this is the really power section. This is what really heats up quite a bit, so obviously it has quite an effect on the components as well, and it's normal that components in this area would be a little bit more wasted than the rest of the circuit. You'll notice that big cap at the bottom there. That has been cut out and replaced, but because it's serving its purpose of holding the wires in place, I left it there. So it's not doing anything except acting as a support for the wiring to the other capacitor. There's the new Magic Eye. It's a 6E1P from Russian. great replacement, and as you'll see in a minute, working very, very well. You can see the resistor that was replaced at the top there as well. Now just a quick look at the inside. You can obviously see where some of the components have been replaced. Very few of those big capacitors were left in place. Most of them were dead or leaking very badly. There is that exception, that one over there and that one over there. I cut them out or desoldered one end, checked for leakage, they were fine, so I left them in place. This here is the transformer, that's fine. So moving right along, that's the cathode, that's the discriminator cap for the FM, which was way off value. Another resistor in there. Very little done over here except for checking. This is the RF stage or section. Now what these guys do on the Philips is they really wire these guys, everything near the tubes, very, very close together. It's quite difficult to get to the pins, and they've also got these separators between part. This thing crosses the tube, so it separates one part of the tube from the other, just so you can reduce interference. Very hard to get in there and replace anything. God help you if you have to change the tube socket. So everything here has been checked. All the way along this is working until I suddenly lost AM completely. Now I had cleaned these piano keys, and the inside of the piano keys is this over here. So you can see how these piano keys move in. These things get showered with contact cleaner. You alternate between them many, many times, clean out the contacts, and everything should be fine. And it was, until I lost the AM completely, and FM was fine and the AM was just dead. However, since I'd replaced the Magic Eye, I was getting a Magic Eye response. In other words, I was getting the signal from the Magic Eye indicating that I was actually tuning AM. And then I realized I'd been quite stupid. These are not the only switches that are in place. The piano keys actually activate two other switches. One of them is this over here. Where is that guy? There, that's the pickup input. Now that's pulled through by a pulley system over there. And when you choose any of the others, it snaps back. Now I actually had cleaned that one because I removed some components from there to check. But the one I missed was this guy over here. This is a sneaky bugger. At the bottom, see if I can, when I hit, you see that? I'm pulling the FM, it goes around there through that pulley, and it goes to the FM activator. Now, when I choose AM, watch, it snaps back. FM, shortwave, FM, medium wave, FM, long wave. Right, so obviously this is that switch that selects between which radio source you're going to get. Now, because the Magic Eye was indicating that I was receiving signals and I was tuning through signals, it could only have been here. And I cleaned everything, I cleaned the switches thoroughly, and it was still not making contact until I realized the problem was not the switches. The problem was actually that wafer that wasn't going back all the way. It was coming out, and then when I did that, it wasn't going back all the way. So it wasn't making contact on the AM contacts. So that didn't take contact cleaner, that took a little bit of WD-40 to basically grease it a bit. And the AM is back. But you know, you could lose hours on this thing if you're unlucky. I mean, it just happened. I just happened to think it had to be the selection between the FM and AM at the audio, or rather at the audio stage. And I just remembered to come and look at the switch, which I hadn't really looked at before, except for some minor cleaning. And that was the solution to that problem. So I've also decided to set the speaker system differently. I've actually created this 10 temporary speaker wire with 3 contacts, a ground and the bass and treble speaker outputs, and that then goes down to the main speakers on the radio itself. And the reason for this is I wanted to hear what it sounded like with the actual speakers in the cabinet, and also I didn't want to test anything without a load. I guess the stage we've got to now is that everything that needs doing to correct and check the electronics is done, and what I need to do next is to do a quick alignment, make sure that it's receiving as well as it can. I think this radio really deserves it. It's a great little piece of equipment. And because the cabinet doesn't need any work, I think the next video will probably be the last one, which will include the alignment, the actual putting this back into the cabinet, and then obviously an actual check on the reception capabilities of this beast. So all right, thanks for keeping us company here. And if you like this, subscribe, and I'll get back to you soon. Bye for now.